Hi guys, this video here is to help explain how to write a z-test. I'm going to show you how to write it with and without data. So let's get started. The basic setup of a z-test, or any test in general, has four parts: state, plan, do, and conclude. In the plan, you're going to write the parameter and the hypotheses. So the parameter, just like in the confidence interval, is going to be the true, mean, whatever you're talking about. The hypotheses are going to be mu, and for the null, it's always going to be equal to. The alternative is going to be the claim. The claim might be that something is less than, something is greater than, or something is not equal to. Okay, so those are going to be your hypotheses, and then you have to write the alpha, the significance level, somewhere in the problem. I typically write it here, whatever it may be. Typically we use 5%, but you can use anything, or it might tell you specifically what to use. Yeah, just you can put it here, you can put it here, you can put it here, it doesn't matter. Okay? When you plan out a problem, you want to check these three conditions. Was the sample collected at random? Was the sample distribution approximately normal? And were the samples considered independent samples? So SRS, usually it'll say it in the problem. If not, you'll have to assume. Approximately normal is a little bit different. If you're given data, you have to graph. All right? You always have to graph and talk about that specific sample distribution. So when you graph it, you've got your choice of your stem plot, histogram, or dot plot. Oops, sorry, can't spell. And you're going to choose one of those three, look at the distribution, and comment on the shape. If the problem doesn't offer data, then you have to try the central limit theorem. The central limit theorem says that if the sample size is large enough, when we consider that to be about 30, that the sampling distribution is approximately normal. So first, you always want to check if there's data. If there's no data, let's go with the central limit theorem. Check this first. Okay, you don't want to use both. You want to check this first. And independent means that the population is at least 10 times the sample. All right, so when you're ready to actually do the problem, you want to write out the formula with substitution and the answer. You want to draw a density curve and shade it correctly. You want to find the p-value, and you want to compare it to alpha. The calculator can do those three things. So this is where your brain comes in, and this is where the calculator comes in, and I'll show you how to do that. And when you're ready to write your conclusion, you're going to write, we do or do not have significant evidence, depending whether you reject or fail to reject. And you'll state the alpha, and then you're going to rewrite whichever one of these you're trying to prove. So let's say it was that one. We do have significant evidence that alpha is 0.5, that the true mean cost of lunch is less than $7. All right? Okay, so let's actually do a problem. And this first problem is going to have data in it, which means I know I'm going to have to graph. Okay? So a growing concern of employers is time spent in activities like surfing the web and emailing friends during work. Suppose the CEO of a large company, this is important, wants to determine whether the average amount of time wasted in an 8-hour day for employees is less than, okay, so there's our claim, the reported 120 minutes, okay, so that's our parameter, and sample of 10, so there's our sample size, and here's our data, so we're going to put that in our calculator. And we're going to try to prove that his employees are on the computer less than 120 minutes for personal stuff. Okay? And we have to do this with the assumption of sigma is 9.45. All right, so let's get started with the state part of this. Okay? So the parameter in this situation is the true mean time spent surfing the web. The null hypothesis is the claim that people spend 120 minutes on the computer, and this CEO believes his employees are better than that, so they're going to spend less time on the computer. And it didn't say an alpha, so I'm going to go with 5%. All right, so these are the four things that you need in the state part: your parameter, your hypotheses, and your alpha. All right, let's talk about the plan portion of the proof. You have to check these 3 things, and it did say that the employees were chosen at random, so we can just go ahead and jump into that. And the next thing you want to do is you want to enter the data that was on the previous. You're might need to rewind if you don't have this data in your calculator already. And remember, you should be pausing the video now and trying this problem on your own, then turning on the video and checking your work. So in my calculator, I've already have the list in here. And I also put it in order already, so I'm ready to go. And I have to choose what kind of graph I want to draw, because I have data, and so I have to draw a graph. So my choices are a stem plot, histogram, or dot plot. I don't want to do a dot plot because it's going to be a lot of dots to draw from 100 all the way to 131. So I'm not going to, I mean on the number line, so I'm not going to do that. So instead I'm going to do a stem plot, and just for practice I'm going to do a histogram. This is also, you can also find this in the z-interval video I made. I showed you, I'm going to go really fast here, so if you need a little bit more help, you can go to the z-interval, and I explain step by step how I did this. So I put my data in order, and when I did that, I have a stem of 10, 11, 12, and 13. And I'm using my calculator and sorting them. I can just fill out my stems, or my leaves, sorry. And so I get a graph that looks like that. So we'll say that's 100 minutes. Okay. Or I'm gonna, I can also use my calculator to draw a histogram. And again, if you need help with this, go back and watch the z-interval. I'm making them, the x is width of 7 units. So these are 7 minutes apart. And the first bar was 2 units, the second bar was 4 units, the next one was 2, there was a gap, and then 2. Okay, you don't need 2 graphs, I'm just showing you an example of 2 graphs. So just pick one, whichever one you want to do, and use that. And if you don't know how I got this, go watch the z-interval video, or just fast forward to the graphing part, and I explain exactly how I got all of this, and I explain how I drew that out. Okay, so we're done with that. The distribution is skewed right. Distribution is skewed right. So you want to make a comment about the shape of the graph, but we want approximately normal. We don't want skewed right. So we have to assume the distribution, I'm just going to abbreviate, is approximately normal. And proceed with caution. Dun, dun, dun. All right, caution. All right, there were 10 employees interviewed. So we said in the very beginning of the problem that it was a large company. So the population is at least 10 times the sample. So in this example, since all of the conditions worked, they didn't, but we're going to proceed with caution. Since they worked, we're going to go ahead and use a z-test. All right. Okay, so to save a little time, I already did some of the do part for us. I wrote down the formula, and I need the numbers to plug in here. And I'm going to use my calculator for all of this, so I'm going to go back to the calculator. I'm going to go to Stat, Test, and I'm going to do a z-test. I have data, and my mu here is 120. My standard deviation was on the very first screen, on the screen that explained the problem, so 9.45. I have data, so make sure you highlight data and then tell it which list to use. And in this example, the CEO wants to prove that his employees spend less time, so pick the less than inequality and go to calculate. And there's the information we need to plug into our formula, okay? So x bar is 114.9 minus mu, which we said was 120, over sigma, which we said was 9.45. So that was given and that was given. And actually the sample size was also given. And so that answer comes out to negative 1. You can just round that to negative 1.71. and the p-value comes out to 0.044. And so let's graph that. So that's at -1, 2, so there's -1.71. It's a less than problem from the HA. Remember, HA is less than 120, so that's why I'm shading that way. And so with that p-value, we can say that that p-value is less than 5%, which was the alpha you chose in the very beginning of the problem. And anytime the p-value is less than alpha, we say reject H0. Because that probability is so low, remember p-value means that that probability is so low that this, we made the assumption that the null hypothesis was true, that this was 120. This is so low that this can't be true. The null cannot be at 120 minutes, okay? So we're ready to conclude. So we, since we rejected H0, do have significant evidence at alpha equals 0.05 that the true mean time spent surfing the web is less than 120 minutes. Okay? So that's how you solve that problem if you're given data. Suppose we had the same problem, but you weren't given data, you were just given statistics. So for instance, you were given the sample size, you were given X bar, you were given sigma, and you were given a claim. All right? The state, the do, and the conclude would be the same. The only thing that would be different is the plan. You would still look if it's a random sample, you would still conclude if it's independent, but this time if you don't have data, you can't draw anything. You can't graph anything. So you have to see, is n large? We said that n being large means greater than 30. We had a sample size of 10. So 10 is definitely not bigger than 30, so the central limit theorem does not apply here. The central limit theorem only applies to sample sizes that are large, and so since the central limit theorem does not apply, we have to say, assume the distribution is approximately normal, and proceed with caution. All right? And then for the calculator, you would just do the same thing. You would go to test, z-test, but instead of data, you would pick stats, and you would plug in the information rather than have it look into a list. All right? So good luck studying for the test, and good luck with z-test.